symmetry in this chapter. 1/3 of the test is just going to be on symmetry questions. So we're going to go through symmetry that you've probably seen before, but then also talk about something called rotational symmetry. We'll get to that after we talk about the symmetry that I know you've all seen before. Reflectional symmetry, or sometimes called line symmetry, is being able to draw a line on a shape so that when you fold it on that line, it would line up exactly and match, okay, like a mirror image on each side. So what I want you to do on these 4 right here is to draw all of the lines of symmetry that you think are on there. I'm going to give you a minute or 2 to do so. So this is also how I'm going to ask you on the test to make sure that you know what symmetry is. I'm going to have you draw them on the pictures. So how many are on this first one? 2 of them? Okay. So you probably got these same 2 then. There's one right here, and there's also one right here. Okay. How many are on the next one?
5.
I see some people saying 1 and some people saying 5. Okay, I think you all agree there's one right here. Okay, there's actually one that goes through every single similar way. Okay, so that one has 5. Number on the next one. I'm seeing lots of 4s. Good. Okay, it's kind of like the first one where you've got this vertical one and the horizontal one. We also have the diagonals too. Okay, the last one. Good, I'm seeing a lot of 0s. There are none on this one. There's no way to fold this in any way. And those of you that are still skeptical, I cut out a piece of paper that's the exact same size as this. You cannot fold it this way or diagonally in any way, shape, or form. It will not land on itself. Okay? So parallelogram does not have any line symmetry. Questions on line symmetry? Okay. I believe that's review for everybody. Okay, this right here is called a fractal. Okay, you can actually take an entire math class just on these shapes. This is actually a graph that they've just added some color to with a computer, but the edges of it are an equation. So the thing about these fractals is that they repeat over and over again, and they zoom in infinitely, and there's always symmetry with it. The math that goes along with this is called chaos theory. It's only been around since computers have been around, because this would take years and years and years and years and years to graph by hand. And obviously this video isn't going to be infinitely long. It's only about a minute. But you could keep zooming in and see them. That's a good question. I don't know if there's a practical use for it right now, but it looks cool. And the thing about these is the equations themselves are super simple and they create these really neat graphs. So for instance, some of these equations are as simple as taking 2 to the x plus 1. Okay, you put in a value for x, you get out a y value, right? Okay, whatever you got for that y value, then you plug back into x, and you just keep repeating that over and over again. It's called an iteration. I took a whole semester class on this in college. It was my favorite class because it was just neat to see what would happen when you have these very simple equations and they create graphs like this. So just little extra thing on symmetry that's kind of cool. So here's the other piece of symmetry that we're going to talk about in this class, which is rotational symmetry, where you turn an object and it lands in the exact same spot. So looking at these two, and we're going to focus on just the first turn. There are pictures where you can turn them multiple times and they will land on the same location. We're just going to talk about that first turn. So how far would you have to turn this picture for it to land on itself again? 90 degrees, right? A quarter turn. So the rotational symmetry on that picture is 90 degrees. What about that next one? That would have to be a half turn of 180 degrees. Okay, I just said this word right here. If they talk about a half turn, they're talking about 180. And point symmetry is specifically referring to half turns. So point symmetry is 180 degrees. So when you see that in the book, and they're referring to, is there point symmetry on this object? They want to know, is 180 degrees one of the turns that you can make? Some are yes and some are no. So we've got rotational symmetry, okay, is going to be anything that is between 0 degrees and 180 degrees. Point symmetry is specifically 180 degrees. Okay, it just has a special name. So we're going to talk about how we can figure out what that first angle is after we look at a few real-life examples of symmetry around us. Okay, so this is broccoli in its very early stages before all the little florets come out. Okay, you can see lots and lots of symmetry there. A honeycomb. Sunflower has lots of symmetry there. Shells, peacocks, spider webs. It's really neat when you find one of those that isn't just like a mesh, it's actually those concentric circle ones. Crop circles. They are not from aliens. Snowflakes, as we figured that out in making all of our beautiful snowflakes on our windows. Galaxies. Sun and the moon, which has infinite symmetry because it's a circle. Okay? Lots and lots of symmetry. So essentially what we're trying to figure out with this rotational symmetry is how far is that first turn. Okay, so we have this hexagon, for instance, and we can turn it here and it lands on itself, right? So we're trying to figure out what that angle of rotation is. Now there's going to be a definite pattern with how to do that. So how many angles of rotation does this particular shape have? How many times can you turn it? 6 times, right? Okay. What's the measure of that first angle? How did you figure that out? 360 divided by 6 gives you that first angle. So what's the general rule going to be? Okay, we can do that. Now, what if it doesn't have sides? For instance, it's a pattern, or it's a star, for instance. Okay, so let's imagine we have, and just pretend that this is a perfect star and it's symmetrical. There's 10 sides on the outside of this star. Are we going to divide it by 10? What are you going to divide it by? 5. So it's more linked to how many lines of symmetry it has. Okay, so don't necessarily think about this as being the number of sides, because it might have a whole bunch of points on it. Or you could think of it as, well, we know this is going to have to rotate here, and there's 5 of them that would have to go around. Okay, so that's how you're going to figure out that first angle of symmetry for rotational symmetry. Questions?